Welcome to another video. Let me introduce to you something called the sigma function, and I'll tell you what it does. If you looked in the thumbnail, there was a question to find the sum of all the divisors of 2025 because we're in the year 2025. So just do this after the video and leave your answer in the comment section. I'll show you how to find the answer for any number. Okay. What does the sigma function do? It helps us calculate the sum of all the divisors of any number. You just add them all up and you get the answer as if you listed them out. The formula can help you do that. This is number theory. Let's get into the video. This would be a very good introduction because I want to show you what this is all about. Now, suppose we say, what is the sum of all the divisors of 6? So let's say 6, and we want the divisors. Okay, so we want to write out all numbers that divide 6. Well, we know we got 1. We got, what other number divides 6? 2. We know 3 also divides 6. And we know that 6 also divides 6. So all these numbers added together will give us 12. So it is really possible, we don't need a formula to be able to find the sum of all the divisors. Okay, now let's take it higher a little. Let's do 7. What is the sum of all the divisors of 7? Well, we know that 7 is just 1 and 7. Those are the only two numbers. So we end up with 8. Okay, that's not hard. What about 8? We know that 8 is basically 2. 4 also divides 8. We know 8 also divides 8. So this gives us 14. Still easy. What about 12? Okay, I'm just showing you the different patterns that you're going to get. And now 12, we know 1 divides, we know 2 divides, 3 divides 12, 4 divides 12, 6 divides 12, 12 divides 12. If we add up all these numbers, we're going to get 6, 10, 16. We're going to get, hey, that looks like 28. Yeah, that's 28. Nice. What if we want to try 120? So the problem with 120 is not that we cannot list out these numbers. The problem is that while listing out the numbers, you might forget to include a number, and that nullifies your answer. What if I add one more 0 to this? What if it is 1,200 that we want to list out? It becomes very difficult for you to do it. So it is just better to have a simple formula with a closed form so that as soon as you break down the number into what we want, you can just use the formula and get the answer without even knowing what the numbers are. Now, this is how you treat every number whose sigma you're trying to compute. Now, you write it as a product of its prime factors expressed as powers. So, instead of writing 16, I write 2 to the 4th. Instead of writing 25, I write 5 squared. The bases must be prime numbers. That's why we have p here. The exponent on each of them is the a. So this is what it means. I'm going to prove this later, but I just want to show you how to use it because this is what's important. Okay? Now, look, we know that the sigma, according to this formula, of 1,200, because this sigma function is multiplicative, which simply means that it follows the multiplication rule. Instead of you finding the sigma of a product, or you can say the sigma of a product is the product of the sigmas. So that's what's going to happen here, and we're going to prove it later, okay? We know that it's going to be the sigma of 2 to the 4th multiplied by the sigma of 3 to the 1st multiplied by the sigma of 5 squared. And now we have our formula. The sigma of any number that has this kind of exponent is going to be the prime factor raised to power a plus 1. So in this case, it's going to be 2. Look, my answer is going to be 2 raised to power 4 plus 1. Okay? 4 plus 1 minus 1 over 2 minus 1. That's the first part. I'm going to multiply it by 3 to the 1 plus 1 minus 1 over 3 minus 1. Using that formula, multiplied by 5 to the 2 plus 1 minus 1 over 5 minus 1. So here, what I have is 2 to the 5th is 32. 32 minus 1 is 31. 31 divided by 1 is just 31. So I have 31 here. What do I have here? 3 squared will be 9. 9 minus 1 is 8. 8 divided by 2 will be 4. This number here is 4. So I go here. 5 cubed is 125. 125 minus 1 is 124. 124 divided by 4 is 31. Oh, did you see that? This is going to be 4 times 31 squared. I know 31 squared just by heart because I know 13 squared is 169. 39 squared is 961. So this is going to be equal to 4 times 961. Just reverse the numbers. 169, 961, 1331. Okay? And what do you get? Hey, what's this dog doing? So 4 times 961 is my answer, and that's going to be 4, and this is going to be 24. I keep my 2, and 4 times 9 is 36, so I got 38. So it's 3,844. I checked it, and I didn't make a mistake, so this is good. Actually, I didn't. I just came up with this number as I started the video, so this is good. But in the thumbnail, your homework is to do for 2025. Don't forget, 2025 is the square of 45. So 45 times 45 is 2025. And I think you can use that to write it in terms of its prime factor. So I just gave you a very easy hint to help you with the problem. Okay, so how did we come about this formula? That would be the second part of this video. If you're not interested in that, this is the time to quit and go do your homework. Okay? The formula you have on the board is the simple formula, and I decided to leave it simple from the beginning so you don't get confused by the complicated formula. This assumes that n has only one prime factor. So this will work for a number like 2 or 4 or 8 or 9 or 25. That is powers of prime numbers or just prime numbers. Okay? So if it only has one prime number and only one exponent, that's fine. But for the example we did for 1,200, you can see that this formula, we had to multiply several of these prime numbers. So this is not the overall formula, but it is the basis. You just need to break it down and write it. The true formula is what I'm about to write. So this is the actual definition. If n is the product of some prime numbers written in their powers, then we can say the sum of all the divisors of n would be the sigma of each of these prime expressions that we have here, which I already explained. And pi is a prime factor. So remember, I is changing from 1 to 3 depending on how many prime factors the number has. We also know that a sub I is the corresponding exponent of p sub I, and sigma is the sigma function. Well, that's a tautology. Okay, so now And something I need to clarify, when we talk about divisors in number theory, always stick your mind to the positive numbers. We know that if you can divide by a positive number, you can also divide by a negative. But for simplicity's sake, we all only stick to positive numbers just to help us do the proofs quickly, okay? If it's true for the positive, it's true for the negative as far as divisibility is concerned, right? Okay, so now, it's just that by the time we do positive and negative and you add them, you're going to always get 0. So that's why it doesn't make sense for you to stick positive and negative together. So here, how did we come about this proof? Let's begin from a very simple case, okay? So, proof. So the first thing we're going to do is we'll take a number that doesn't have multiple prime numbers, only one simple number, okay? So let n be some number that has a prime factor raised to power k. Only one prime factor. So a good number would be all prime numbers behave like this, and all powers of prime numbers behave like this. Like 27 would be 3 to the third, 8 will be 2 to the third, 25 will be 5 squared. That's the kind of number we want to start with, because that's what each of these will be ultimately in any number. There's going to be a prime number raised to a power. So let's start with the skeletal case. Now see what happens. What are the divisors of this number? Well, we know 1 always divides it. So the divisors of n are, let's make a list. The first number is 1. The second number is p, the prime number itself, right? The next number is the prime number raised to power 2, okay? So it's going to be p squared. The next number will be p cubed. It continues until it gets to p, the highest power, which is p to the power k. So it means that if we try to compute sigma n, the sigma of n is just going to be this plus this plus this plus this, right? So it's going to be equal to the sum. Do you see what's going on? Have you seen this before in your algebra class? Yes, this is a geometric series where the common ratio is p. You can see, you multiply this by p, you get the next one, get the next one. And we can find the sum of a geometric series. Now, how many terms will this have? Well, it will have how many terms? From here to here, 1, 2, blah, blah, blah. There are k terms here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, k. So there are k terms plus 1. That's where this a sub 1 plus 1 came from. So, this is a geometric series with k plus 1 terms. Maybe I should use a, since I'm using a here. You know what? Let's use a. Okay, so this is going to be with a plus 1 terms and common ratio and common ratio of p. So what is the sum of a geometric series with this property? We know the sum of a geometric series with how many terms? With a plus 1 terms is equal to r raised to power, let's do n first, with n terms, okay, is raised to power n minus 1 over r minus 1. Remember, as long as the common ratio is greater than 1, and we know every prime number is greater than 1, that's why we can stick to this. We know that r is greater than 1 for all prime numbers. So in this case, if we plug in this number, remember n is the number of terms. This n is not the same as the n we're trying to find. I wish I could change it. But I just want you to see, you see it? Okay, since you've seen it, I'm going to change it. The number of terms in this picture is a plus 1. The number of terms here, we're going to change this to a plus 1. And the common ratio is actually what we call p. This is p. Boom! P is greater than 1. That is the formula that I wrote on the board initially. The only thing we need to show now is that if you have multiple prime numbers, you can just treat them separately and multiply the answer, which means we want to show that the sigma function has the multiplicative property, that is, the sum of the divisors of the product is the same thing as the product of the divisors of the sum. That's big grammar. Okay, let's put that on the board. So what we're going to say is, so here we go. We can say easily, therefore, the sigma of n, okay, let's put it, sigma of p to the a is, oh, that's what I should do here. So I can change this. Sigma of p to the a will be equal to p to the a plus 1 minus 1 over p minus 1. We have done the first part of this proof. Okay, so I think I can change this to a. So we want to show that the sigma of mn is equal to the sigma of m multiplied by the sigma of n. Just that. How do we do that? Well, let's see. Remember, we said that this case I had, this is a prime number. So every expression is relatively prime to the other. So let's just do some basic claim here. So we can say that, let's assume that m and n are co-prime. Okay? That is, the GCD of m and n is 1. The only number that divides both of them is 1. Okay? Okay. Let d be a divisor of mn. Okay? If d is a, remember we're talking about the sum of the divisors. Let's just pick any random divisor of mn. Then, based on the rules of divisibility, if d divides a product of two relatively prime numbers, then d must have a way of being written as some, I'm using, you know what? Let's do RT. Okay? D equals RT. Where R must divide M and T must divide N. Let me give you a good example. Take 4 and 9, for example. Okay? What is 4 times 9? Remember that you get 36. 4 times 9 is 36. These two numbers are relatively prime, right? Any number that divides 36 there has to be a way to write it in terms of, to write it like this, where the first number divides 4, the second number must divide 9. So pick all the divisors of 36. Let's start with 1. Well, 1 can be written as 1 times 1. Let's pick 2. 2 can be written as 1 times 2. 3 can be written as 3 times 1. Remember, every number, the two pairs you're multiplying, one of them divides this, the other one divides this. That's the whole point. If you pick 6, for example, 2 divides 4, 3 divides 9. Pick 12. Well, 4 divides 4 and 3 divides 9. Pick 18. 9 divides 18 and 2 divides this. So every number that divides 36 can be written as in the product of two divisors of these. So this is the fact of it. Okay? We need this. So as you see, every time you pick a divisor of mn, that divisor can be written as a product of RT, where R divides M and T divides N. Okay. Similarly, or conversely, let's put it that way, conversely, if R divides M and T divides N, then this is a fact of arithmetics that RT divides MN. Okay, I like this fact. This is a beautiful one that we use more often. Okay, if two numbers, for example, the only way you know that 72 is divisible by 24 is because 72 is divisible by 3 and 72 is divisible by 8. Because 3 and 8 are relatively prime, then you know they are. So if R divides M and T divides N, then the product of R and T must divide Mn. Now, we have gone in both directions. This is called a bijection because everything here follows this and everything here follows this. So we've gone in both directions. It is a bijection because it is true in both directions. That whatever you are doing here is what you are doing here. Okay? The divisors of Mn basically imply that you are taking R and you are taking T. Okay? Let me show you what that means. The sum of all divisors such that this divisor divides Mn is the same thing as the sum, well, there are two numbers involved here, okay, of RT, where R divides M and T divides N. This is the mathematical notation representing this. The sum of all divisors, D, will be the same thing as the sum of all RTs. Now, don't let this notation confuse you. This is the sum of products. If you don't see it, you might see it first as a product that is being summed. Okay? I know it's confusing, but watch this. If I said 1 plus 2 multiplied by 3 plus 4, is this a sum of products or is it the product of sums? It is whatever you call it. Okay? It depends on what you choose to do first. Right now, this is going to be the product of sums, but it could actually be the sum of products. For example, if you distribute, what is 1 times 3? You have 1 times 3 plus 1 times 4 plus, what else do you have? 2 times 3. 2 times 3 and then plus 2 times 4. So notice this is the sum of products, which is what we want. This is the product of sums. So this is the product of sums that we want this. But right now, this is what we have because of the summation notation. But this and this are exactly the same thing. And that's what we're going to do. Okay? We're going to split this because we're allowed. You can convert this to this. It's more like you're doing factoring. The process of factoring converts a sum into a product. That's what we do in factoring. Yeah? Sum of terms becomes a product of terms. That's what we're doing here. So we're going to change this sum into a product because it is allowed. So we can say that the sum of all divisors of Mn is equal to the sum of all divisors of m, r divides m, multiplied by the sum of all divisors of n, which is t divides n. This. And if there's another one, because we have established the multiplicative property of the sigma function, you can now do this too, then multiply by the next one, then the next one, then the next one. But this is it. This establishes the multiplicative property of the sigma function. Therefore, sigma mn equals sigma m times sigma n. Cha. Don't forget your homework. Never stop learning. Those who stop learning, stop living. Bye-bye.